Hey everyone, my name is Sarah Bhattarai.
And my name is Annette Cumins.
And we are STEM educators for 4-H in Weber County.
Today we are going to show you how to explore the universe and take images of celestial objects, all from the comfort of your very own home.
All you need is an internet connection. We are going to be using the MicroObservatory Robotic Telescope Network, which is operated by the Harvard-Smithsonian Center for Astrophysics. This is a network of automated telescopes that you can control over the internet. These 3-foot-tall reflecting telescopes are physically located at the Harvard College Observatory in Cambridge, Massachusetts, and the Whipple Observatory in Amado, Arizona.
These telescopes have been designed to be accessible for youth all over the nation.
To access the telescopes, open up a web browser and go to microobservatory.org.
Click on this Observing with NASA button, which is in the MicroObservatory Access portals. The first step to taking images is to click on the Control Telescope in the upper left-hand corner. And now you get to choose your target. So I think today I'm going to choose the Orion Nebula. Okay, so here we have a couple options. You can choose the field of view. Next, we have exposure time. Objects that are relatively bright and close, you should use a short exposure time, like 0.1 seconds. It's so bright that it's going to be overexposed very easily. However, the Orion Nebula is pretty far and it's pretty dim, so I'm going to need a longer exposure time in order to allow my camera enough time to collect enough photons to give me a good image. Let's try 60 seconds. Sweet, optimal exposure time. Okay, and the last choice we need to make is our filter. We can have no filter, we can choose only red or green or blue, or if we want to make a true color image, we can choose the multiple filters option, and that is what I'm going to do today. Great, now all we need to do is provide our contact information and then hit submit. Now I have to wait a few days to get my images. Sometimes the weather is not ideal and you'll get a cloudy image. Here's hoping for good weather. You'll find a link in your email to download the FITS files. Now make sure you follow the instructions and download the FITS files. Okay, so now that we have our 4 images, we're going to go back to the MicroObservatory page. And we're going to click on this tab that says Analyze Images. This is going to take us to the JS9 program. JS9 is a program that we're going to use to process the images, and you can access this program through your web browser. If you would like to see more detailed video tutorials about how to use this program, then you can click on this link right here that says Video Tutorials. You can also click down here, Video Tutorials. So the first step is I need to upload my own FITS files. Right now, it looks like they have the standard Lagoon Nebula file. I'm just going to exit out of that because I don't want it. Now first go to the Image tab, click Open, and then choose all 4 files. Make sure you've got the 3 different color filters and your dark image. And now if you go to My List, you will notice that you've got all 4 of them listed.
Now we need to subtract the dark calibration image from each of the filter images. This is basically isolating any background noise that comes from the camera and taking it out of our images.
Let's start with the top one. When you click on a file, it will show up as green, and that's going to be the one that you're working on. Even though all 4 of them are open, that's the one we're working on. Now go to on the Tools drop menu and go to Image Math. We want to go to Subtract. We want to click on Subtract, and then we want to click on Dark. What this is saying is we're going to subtract the dark from this current file. Hit Run. You'll notice that our image got darker. That's totally fine. Let's do that again for the other files. Image Math, Subtract, Dark, Run. Great.
Now we need to change the scale. Go to the Scale drop-down menu and choose Log. We use a logarithmic scale for interstellar objects because they are relatively dim. If the object was in our solar system, we would probably prefer a linear scale.
And look at that, I'm already seeing more detail. And now in order to see more detail in this image, we need to change the low brightness limit and the high brightness limit. Those controls are here on the right-hand side. Right here, it will tell us the pixel value of wherever our cursor is. Where it's brighter, we're going to have a higher pixel value, but where it's darker, we'll have a lower pixel value. So let's find the lowest value we can on this image. Usually I find it in a corner. Okay, the lowest number I'm seeing is like 45. Change your low brightness limit to whichever lowest number you see in your image. It's going to be different for every single image. Wow, huge difference already. Okay, I'm also going to change my high brightness limit. Look at that, 3831. So I think I'll just go 4000. In this case, it really did not make much of a difference, but I'm still happy with it. You can also change the stretch, contrast, and the shift bias. However, in this image, that's not necessary for me, and so I'm not going to go over it right now. You can find out more information about how to use these tools from the MicroObservatory tutorials. Okay, let's do this to our next image. Okay, so now that I've processed all 3 of my images, I need to assign each of them a color. In order to assign it a color, I need to know which filter was used to take this image. So go to the image drop-down menu and click on Display Fits header. This is going to give you all of the information that comes with your fits file. If you scroll down a little bit, you will notice that the filter is red. Great. Also, fun fact, this will tell you which telescope took your image and the name of the telescope. It looks like this telescope was named Ben. So thank you, Ben, for taking such a beautiful image of the Orion Nebula. All right, so this was red. Go to your color drop-down menu and click on red. Instead of making your highest pixel values white, it is now going to be red, and everything is going to fall somewhere between black and red. Okay, so now we need to combine all 3 of our images into one image to be a true color image. Okay, so first thing, go back to my list and I need to get rid of this dark image. We're done. Thank you for serving your purpose, but now it's time to go. Now I've got the 3 images and they have all been assigned a color. They've all been processed. We're good to go. So go to the color drop-down menu and we're going to click on RGB mode. What this is going to do is it's going to display all 3 of the images on top of each other. Boom! I am seeing the color. It looks really cool. But you're going to notice that they're not lined up properly. Look at this star right here, guys. Do you see those stars? Okay, no big deal. We just have to line up the 3 images. Couple things we got to do. First, I need to shift the red clear up here. The way you do that is go to the Tools drop-down menu and click on Shift. Another tool that's helpful is a magnifier. See, look, magnifier is nice. Okay, so I'm on red. I'm going to shift the red up by like a lot. I'm going to try to line up these stars right here. So the trick to lining up images is that you pick on a bright star that doesn't really have a lot around it. You focus on that. So there's another trick you can do, which is zoom. Perfect. Now let's reset our zoom and wow, check that out, dude. That is Orion's Nebula. I'm very happy with how this turned out. To save it is you go to Image and Save As. You can choose to save it as a PNG or a JPEG. Let's see what it looks like. That's so pretty.
Is this the kind of thing that you'd be interested in doing?
Utah State University offers a variety of STEM degrees. These STEM degrees include
Climate science, physics, biochemistry, computer science, data analytics, and environmental engineering.
I hope you enjoyed it. Thanks for watching. Bye.